Welcome to my YouTube series called Code Along with Me. This is by no means a tutorial on how to program or how to code with certain languages. This is mostly just for me to have fun and showcase various technologies that I enjoy working with. And in this case, I wanted to show off concurrency in the language of Golang. And if that sounds appealing to you, stick around. If not, I'll catch you later. So to jump right into it, concurrency in Golang. It's Golang's most attractive feature in my mind. It's what brought me to the language, and how simply and elegantly it handles concurrency is, I think, what makes the language very modern, and it's one of the reasons why Go is starting to become increasingly popular. Coding in concurrency with concurrency in mind is definitely a different paradigm than what a lot of programmers are used to. But in this video, I wanted to show you just how powerful it can be. We're basically going to take a rudimentary port scanner, a program that basically checks for open TCP connections at certain ports at a certain host, and we're going to time that rudimentary version and see how it matches up with a refactored version that implements concurrency. So yeah, without further ado, let's get started. This website I'm using, by the way, is Replit. It's great if you just want to get down and dirty, start coding without the hassle of downloading Go and figuring out how to configure it. So yeah, great website. You get to configure it however you like it. I'm using Vim key bindings. Great website. So in order to establish TCP connections, we're going to use this package called net. And again, this is a very rudimentary program. We're just going to make a basic for loop, and we're going to scan ports 1 through 24 to see which one is open at this website called scanme.nmap.org. So there it is. I'm getting used to this keyboard, so forgive me, it's brand new. It uses blank caps. So, okay, forgive me about that. Anyways, so we're first going to construct the address, which is going to be a formatted string, and it's going to be, again, this website, scanme.nmap.org, and we're going to scan various ports. There it is. And then we're going to try to establish a connection using net.dial. Again, this is going to be a TCP connection. Then we're going to stick in the address. Now, if the connection is closed, we can expect a non-nil error. And what I'd like to do in this program is to basically take all of these closed ports and stick them in an array called closed ports. And I'd also like to do the same for the open ports. So let's go ahead and declare a closed ports variable. And we're also going to do the same for open ports. There you go. And if the connection is closed, we're going to append that port number to closed ports, and then we're going to continue the loop and not read anything below. But otherwise, we're going to append to open ports the open port number, and to be polite, we want to close the TCP connection once we establish that it's open. So, and then afterwards, I want to print the open ports open ports. And then the last thing we need to do, obviously, is time the function. So to time functions in a very rudimentary way, this is not how you should actually time things in production, but for our purposes, this will work just fine. Start time.now, and then we're going to want to print the elapsed time.since the start. And there you have it, our very rudimentary port scanner. Let's go ahead and run that. There you have it. Port 22 is open. The rest seem to be closed. And our program took about 1.03 seconds to run. So, this works just fine, but you can imagine that if I wanted to start scanning the well-known ports up to 1024, this program could take quite a long time. And, hypothetically, since there are like 65,000 TCP connections at a given host, you can imagine that this will take an incredibly long time. So that's where concurrency comes and saves the day. So to begin refactoring our program to make it utilize concurrency, the first thing we're going to need to do is identify the most expensive component of our code with respect to time, and it is obviously going to be this part, which checks to see if these TCP connections are open or closed. So what I imagine myself doing to make this program run faster is that every time we loop through our for loop, we're going to stick each process into its own individual thread of execution. And, that's what a go routine is. Though it's worth mentioning that a go routine is not the same thing as a traditional thread. It's actually much lighter weight, and you can actually have multiple go routines running on the same thread. But that's a detail that we won't cover right now. Just worth noting. Again, we're going to take these guys, each individual process, put them in its own go routine, and have all 24 of these processes run concurrently rather than sequentially. And we can expect this to speed up our program by a lot. So let's go ahead and get started on that. What I imagine myself doing again is I'm going to make another function called worker. I have no idea what the parameters are going to be just yet. I'll know as I write it. Let's go ahead and take this code right here, stick it right there. Let's go ahead and fix the indentations. There you go. And okay, so obviously I is going to be passed through the port number, p int. So let's go ahead and replace these i's with p's. This guy I'm going to talk about in just a second. But let's see here. All right, yeah, that looks good. So in order to make this program run a lot quicker, what I imagine myself doing is not doing the appending logic here. I'm just going to have this worker function specialize in one thing, and that's determining whether or not a connection is open or closed. And once that's determined, I'm going to send that data through a channel, and then the receiver is going to receive the data, and then that guy is going to be responsible for appending the proper port numbers to the appropriate slices. So let's go ahead and get rid of this guy. So I'm going to have a channel called closed port channel, CPC, and I'm going to send the data, the port number, through to this channel if there is a non-nil error, which again implies that the connection is closed. And I'm going to change this guy to, open port connection. There you go, and I can't have it continue inside of a loop. I'm just going to return nothing, since that's what I determined my function to return. And again, we're going to have two channels, the open port channel and the closed port channel, both of which are going to be type channel ints. And let me fix that guy right there. And now I need to declare these channels. So open channel, the open ports channel, I'm going to make using the built-in make function, which again is just going to be type chan int. And I'm going to do the same thing here, but I'm going to call it closed channel. And there you go. Now I have everything I need to invoke this function. And my thing just froze. That is so strange. There you go. Sorry about that. So I'm going to stick these function calls inside of their own individual Go routines, and I'm going to pass in the port number, and I'm also going to pass in the open channel and the closed channel. So now that I have those guys ready to fire, ready to go, the last thing I need to do, obviously, is have like a receiver ready to get the data that is being sent through these channels and sticking them into the appropriate slice. So the way I imagine myself doing that, again, is to use a Go routine. I'm going to create an inline function Don't know what the parameters are just yet, but I'm going to create a for loop that is going to run the same amount of times as the amount of times I'm checking which ports are open. So that's going to be I is equal to 1, I is less than or equal to 24, and then increment I each time. And then inside of this for loop, I'm going to use a select statement, which is basically going to listen for which channel is spitting out data at any given time. So, for example, I'm going to also, closed open port channel. So if the open port channel spits out some data, I'm going to assign it to a variable num, and then I am going to append it to my slice open ports. So I imagine myself passing in a pointer. Oops. There we go. I imagine myself passing in a pointer to this function, and let's just call it OP for short. So dereference OP, and then I'm going to append to it that number. And the same thing goes for the closed port channel. But in this case, I'm going to pass in the closed ports, and there you have it. There is our listener function. And let's see what we need here. We're going to need the channels as well as pointers to our slices. So let's pass those guys in first. So we got the closed open port slice, and we have the closed port slice, both of which are going to be pointers to an int and a slice of ints. And then we also have our channels. Let's see what they're called. OPC and CPC, both of which are, again, type int. And there we have it. And once this guy is done running, once our for loop is done running, we always want to close our channels, because by this time we're done. So let's go ahead and close our open port channel. Ooh, what is that? Oh well. And we're also going to close our closed port channel. And let's see if that looks good. That looks good to me. And now the last thing we need to do, let's see here. Oh, that's right. We have to close down our function. So let's pass in the proper parameters. We have the open port slice and the closed port slice. So open ports and the closed ports. That's right, both of which have to be pointers. And then we also have to pass in our open port channel and our closed port channel. So open chan and closed chan. That looks good to me. We're almost there. The last thing we need to do, again, because all these Go routines are running concurrently, we don't want a scenario in which things are happening, not necessarily in the order in which we want. We want all of these Go routines to run not necessarily at the same time, but we do want them all to sync up and finish at the same time. Otherwise, it'll be a big mess. Our program will get very confused. And so what we'll need to do is use this package called sync. Oh, okay. Just to stick to proper Go convention, let's put things in alphabetical order. And wait groups are very simple to use. Again, one of my favorite features of Golang, which makes the way it handles concurrency so elegant. So let me just show you how it works. So we're going to basically declare a wait group, WG, which is going to be a type sync.wait group. And every time you invoke a Go routine, simple. Just tell your program that you're going to have one Go routine, and then inside of your function, you're going to defer the completion of that Go routine. And again, wait groups are basically a way to tell your program how many Go routines are running at once, and then when a Go routine is finished, when a call to waitGroup.done is called, then you're going to decrement the counter, and it just keeps your program, it allows your program to figure out how many Go routines are running at the same time, and therefore what do I need to sync up? And I'll explain more of that in just a second. And so I'm going to pass in a parameter, weight group, which is going to be a pointer to sync.weightGroup. And there you have it. And for each one of these Go routines that are called, I'm going to, again, increment the counter by 1. Oh, that's right. I need to pass it in as well. I need to pass in the pointer to the weight group. I'm going to add it, and then inside of my worker function, I'm going to defer the closing or the finishing of that weight group. So weight group, which is going to be a pointer to sync.weightGroup. There you go. Pass in the weight group, or rather a pointer to that weight group. And we're almost done. The last thing we need to do is to tell the program to wait until all Go routines are finished. Do not execute anything below until all the weight groups are finished. I'm sorry, until all the Go routines are finished. And there you have it. Here is a refactored version of our original code. Let's see how fast it runs. How much quicker it runs, rather. So about almost 1/10 of a second, or 1/5 of a second, compared to 1 whole second. So that is a noticeable boost in performance. It basically, almost by a factor of 10. Yeah, so again, noticeable performance bump. You can imagine that if I wanted to scan 1,024 ports, or even like 10,000 ports, or 65,000 ports, the concurrent method is going to be much preferred. It's a bit more code, and it's a bit more complicated to parse, and again, because programming concurrently is such a different paradigm from programming synchronously, which is what everyone does and is used to, and that's how they start learning. It takes a little while to get used to. You have to kind of think ahead and then jump backwards and think retroactively. But once you get used to it, it'll open up your programs to this whole new world of performance. So, could I have written this program better? Yeah, probably. There's probably a lot of things that are unnecessary that I did, but this is just, a quick and dirty way to showcase how awesome concurrency is in the world of Go. If you could find better ways to make this program run even faster, please don't hesitate to tell me in the comments. And thanks for checking out my video, guys. More to come in the future. If there are things you'd like to see, if there's things I could do to improve the quality of my videos, please let me know. And, catch you later.